Here's the introduction to section 2.4. There are really just two facts that we need to motivate. Instead of prove them for you with limits that I'd have to wave my hands at, I am going to motivate these facts for you. One just by sketching, and one I have posted a couple of short animation videos on Canvas that you can check out if you'd like. So the first question we want to investigate is, can we use the graph below to sketch the derivative of sine? Okay, so here is sine of x graphed from negative 2 pi to 2 pi. And we can start thinking about what its derivative might look like. Well, we know the derivative would be equal to 0 when sine reaches a maximum or minimum, right? Or when there's a horizontal tangent line. Horizontal tangent lines have slope 0. And so there's a whole bunch of horizontal tangent lines. So at those points, the value of the derivative would be 0. So there's a point on the derivative. There's a point on the derivative. There's a point on the derivative, and there's a point on the derivative. Okay, so that tells us when this derivative hits the x-axis in this case. And then we can think about, now let's break this down into pieces. Let's look at two chunks. Let's first look at this chunk between those two spots where it hits the x-axis. If we look at that chunk, we see that any tangent line we draw would have, any tangent line we draw would have negative slope. And if we look closely right here at pi, and we were to try to draw in a tangent line, the slope of that tangent line would look very much like negative 1. We see negative slope in here. And it looks like it's negative 1 right about here. And it's negative, and then it starts to increase back up to 0. And then if we look in this next window, all of the tangent lines would have positive slope. And they would have positive slope, and it looks like right here at 0, if we were to zoom in, we'd see a slope that's pretty close to 1. And so we keep playing that game. It looks like where sine hits the x-axis, the slopes of the tangent lines are either positive or negative 1, and it allows us to draw a picture, a sketch of the derivative that looks something like this. So there in red is a sketch of the derivative of sine of x, and if we look below, that is exactly the function that's graphed below. That is the function cosine of x. So this motivation would allow us to see that the derivative with respect to x of sine x is in fact cosine of x. Okay, so there's a fact that we're going to need. It's going to come in handy quite a bit. Let's do something similar for cosine. If we do something similar for cosine, let's see, it's going to be 0 again where we have horizontal tangent lines. The derivative is going to be 0, so the derivative is going to be 0 there. The derivative is going to be 0 there. We have a horizontal tangent line here. Another horizontal tangent line here at pi, so the derivative would be 0. Another horizontal tangent line at 2 pi, so the derivative is 0. Okay, and then let's break this down into segments again. Let's look from negative 2 pi to negative pi. Let's look on this window. And what do we see? We see again that the looks very similar to the picture above. So the slopes are all negative, and it looks like they're approaching negative 1 right here where we hit the x-axis. So there would be a point on the derivative. And if we look at this next piece, the slopes are all positive, and here at minus pi over 2, we would reach a slope of 1. And we keep doing this, and we can plot these points that look like this, and we can get this rough sketch of the derivative of cosine. That looks very much like the function above. Sine, it hits the x-axis at all the same points, negative 2 pi, negative pi, 0 pi, and 2 pi. The only problem is here we see a maximum up here reached here, and here that thing is flipped down below the x-axis. So it's the sine function, but it's been flipped over the x-axis. And to flip something over the x-axis, we multiply it by a negative. And so this derivative is negative sine of x. So two key facts. The first, the derivative with respect to x of sine of x is cosine of x. And the second, the derivative with respect to x of cosine of x is negative sine of x. Those are the two things we need to be able to work on the activity for section 2.4. If you'd like to see an animation of those things being sketched out, you can check those videos. They're really short that I posted on Canvas. And other than that, take a stab at the activity.